I'm going to start again with this problem. This is the second part of the video. I had a problem with the first part, and then it crashed, and so I'll start the second part. So what we're going to do is we're going to work this problem out, and this is a word problem. Notice that what it's asking is it's asking for what's the width of the field. So I want to know how far it is from this point to this point. And I also want to know how high the field is. And that's going to occur halfway between the two places for the length of the field, because these points are really going to be x-intercepts. It's where the x value, where the y value is 0. That's going to be where the ball starts, or we're on the ground here, it slopes up, and then it's on the ground again here. So this is the place where y actually is equal to 0, the x-intercept. So let's look at the equation form. We have y is equal to a negative 0.000234 times x minus 160. And that's intercept form. So if I find the place where this value of x goes to 0, which of course would be x equal to 0, and this factor over here goes to 0, that'll be x is equal to 160, I'll find the places of the x-intercepts. So I know now that this place on this side would be the point 0, 0. Over here, the other point would be 160, 0. So I have the width of the football field by looking at my intercept form and finding out where the x-intercepts are. So the width of the field equals 160, and I don't know, it'll be feet. Okay, the next part of the question says, how high is the field? So that's going to occur at the vertex, which would be right about here, and that would be exactly halfway between the two x-intercepts. So if it's 0 here and 160 here, halfway in between, I'm going to have an x-coordinate of 80. So where x is equal to 80, that's going to be the coordinate of my vertex for x, and I need to find the y. So to find the y, what I'm going to do is I'll take 80 and put it into the x's in the equation. I'll get y. So the y value is going to be equal to a negative 0.000234 times 80 times 80 minus 160. Okay, so let me work that out. And so if I multiply that out, what I'm going to get is I got 1.5 feet. So this would be 80 feet out. It's going to reach a maximum height of 1.5 feet. Okay, let's go on to the next one. Okay, this one has to do with a jumping frog. And once again, the frog is going to jump from the starting point here to its ending point here. And halfway in between is where it's going to hit its maximum height. That's going to occur halfway between these 2 points. So it depends on what kind of equation I'm giving on how I'm going to work it out. And let me erase this previous stuff. It looks like this is where the program crashed before. So the equation that I have is y is equal to a negative 0.2x squared plus 1.3x. And this is standard form. So I need to find the value of the vertex in standard form. So to do that, the x-coordinate of the vertex is a minus b all over 2a. So let's substitute in b. That would be a negative 1.3, because that's the b value, over 2 times a, which would be 0.2, a negative 0.2 times 2. So that's going to be equal to a negative 1.3 all over a negative 0.4. And I got 3.25 feet. So the distance to the vertex here is 3.25 feet. So to find how high it jumps, I'm going to have to put 3.25 into this equation. So y is equal to a negative 0.2 times 3.25 squared plus 1.3 times 3.25. And the value I got, if I multiply that out and add so I would have the y value would be equal to 3.575 feet. So the height of the fall would be 3.575. That would be the top of the vertex. Okay, now we're going to move on to looks like the focus form of a parabola. And remember, there are two basic equations that we're going to be dealing with if the vertex is at 0, 0. One of them is going to be y is equal to 1 all over 4px squared. That's when the parabola opens up or down. The other one is going to be x is equal to 1 over 4py squared if the parabola is open left or right. So on this first problem, we can see that the parabola is opening down. So I know that this is going to be an x is equal to 1 over 4p times y squared equation. And what I need to do is find p. Well, if the directrix is up here at 3/4 away from the vertex, then the focus would have to be down this direction. And its coordinates would be 0, a negative 3/4. So p would be equal to a negative 3/4. So let's go ahead and plug p into the equation. So I have x is equal to 1 all over 4 times a negative 3/4 y squared. So if I'm multiplying the denominator, these 4's are going to cancel. And I'm going to have x is equal to a negative 1 over 3 y squared. And that would be the equation of that parabola. Over on the other side over here, this is going to be, wait a second, I did this whole first one wrong. Sorry, it's going to be the same thing, but this is opening down. This is the equation form. X is equal to 1 all over, let's try it again. Y is equal to 1 all over 4p x squared. And if I put a negative 3/4 in there, y is equal to 1 all over 4 times a negative 3/4. I would get y is equal to a negative 1/3 x squared. And that's better. Okay, this next one over here, it opens left to right. That's x is equal to 1 all over 4p y squared. So we need to find the value of p. We have the value of the directrix as a negative 2, so this is a distance of 2 from the vertex to the directrix. So the focus will be to from the vertex going the other direction. So the point of the focus would be 2, 0, and p would be equal to 2. So let's go ahead and substitute that into this equation. X is equal to 1 all over 4. Now p is 2, so let's put the 2 there. Y squared, so x is equal to 1 over 8 times y squared. Okay, the next two are word problems. They're words, and we have to find the equation. So let's draw a little picture. For the first one, we have a directrix as y is equal to 8/3. So if I just drew a quick little graph here, we would have y is equal to 8/3, which means this parabola is going to open downward. And it's going to have a focus here at 0, a minus 8/3. So p is equal to a minus 8/3. Since the parabola opens down, this is going to have the form of y equals 1 over 4p times x squared. And let's plug the p value in. So that's going to be y is equal to 1 over 4 times a negative 8/3 x squared. So that's going to be equal to y is equal to 1 all over a negative 32 all over 3 times x squared. Now, to get this part of the denominator up to the top, we can take it and multiply it times a negative 3 all over 32, the reciprocal of the denominator. So the top has to multiply by a negative 3 all over 32. Since I multiplied the denominator by its reciprocal, it's going to become 1, and the numerator will be equal to y is equal to a negative 3 all over 32 x squared. Moving on to the next problem, let's draw a little picture. We have a focus at a negative 4/5, 0. Okay, so that's going to be over here, which means that the parabola is going to go this way, because that's the focus that I just plotted. Of course, the directrix would be over here at x equals 4/5. So my value of p is going to be equal to 4/5 negative. Okay, so let's put that in the formula. You can see this is opening left and right. So this would be x is equal to 1 all over 4p y squared. X is equal to 1 all over 4, and now we said p was a negative 4/5 y squared. So that would be 1 all over a negative 16/5 y squared, and like before, I'm going to take the numerator and the denominator by the reciprocal of the denominator, so this would multiply at the top would be a minus 5/16. The bottom would multiply by a minus 5 over 16. The denominator would become 0, and the top would be a negative 5 over 16 y squared. Okay, now we're going to deal with some parabolas that actually have the vertex shifted. And the definition of P, it is the distance between the vertex and the focus. So if I look at this, and you can see that these things are going by 2, so that's going to make it a little more complicated, then what I really have is this distance between the the vertex and the focus is 2, 4. So this distance here is 4. So P, and since it's on the left-hand side, P is going to be, it's going to the left of the vertex. P is a negative 4. So let's go ahead and put that there. P is a negative 4. And we know that the parabola opens left, so this is going to be an x is equal to 1 all over 4p y squared, and let's put in that value of p. So I have x is equal to 1 over 4 times a negative 4 y squared, so x is equal to a negative 1 over 16 y squared. That would be the this parabola without any shifts. But now let's go ahead and put in the shifts, right? Because what we see is that the vertex really isn't. So what I did is I found the a value. Because remember, when these things have a shift, this particular parabola is going to be the form of x is equal to kind of 1 over 4p, which we can think of as a, times, actually, y minus k squared plus h. So what we did is we found the a portion, or the 1 over 4p. Now I'm going to put the shift in there, and so let's see where the shift went from. Okay, so it went to the left 1, 2, or 2, 4. So H is a negative 4. For K, that's how much did it shift up or down, and K would be 0. Okay, so let's put that part into this equation. So we would have X is equal to 1 all over 16. And then we would have Y, and the K value is 0, plus H. Now, since there isn't any K shift, we don't have to have this part in parentheses, so X is equal to 1/16 Y squared minus 4. All right, the next one, what we have is this is going to be the type of parabola that opens up or down. This will have the equation form Y is equal to 1 all over 4P X squared, but since the vertex is shifted away from 0, 0, we're going to have to add that shift in. So this equation will be Y is equal to 1 over 4P X minus H squared plus K. And what I need to do is we need to find out what the P value is so we can put it in this part of the equation. And it looks to me like we have this is also going by 2's. So we got 1, 2, 3 divisions. So this distance here is a negative 6 between the vertex and the focus. So P is a negative 6. All right, so let's go ahead and put that into the equation. So we will have Y is equal to 1 all over 4 times a negative 6, X minus H squared plus K. Y is equal to 1 over a negative 24, X minus H squared plus K. And now let's add the HK in. So let's see how far away it shifted. This point is going over to the left, 1, 2, 3, so H is a negative 6, and the K value is it shifted down to 4, so K is equal to a negative 4. Okay, so let's go ahead and put those in to the equation. So I would have Y is equal to a negative 1 over 24. Now I'm going to have X minus H, so X minus a negative 6. And now I have plus K, and we said K was a negative 4. Okay, identify the vertex, focus, directory, and axis of symmetry of the parabola. Okay, so what we would have here is H is equal to a negative 3, K is equal to 2. So my vertex of this parabola is going to be equal to a negative 3, 2. All right, let's find the value of P. So I'm just going to take a look at this 1/8 portion, right? Because the equation would be Y is equal to 1 over 4P X minus H squared plus K. So we can just concentrate on the 1/8 to find P. So I'm going to say 1/8 is equal to 1 all over 4P. So P must be equal to 2. Okay, so let's draw a little diagram and we can figure out what happens here. Is we have this parabola, and since it's a Y equals to X squared, it's actually going to be opening up, and it's going to have a vertex at a negative 3, 2. Let me make it bigger though. Okay, so the vet P is how far away the focus is from the vertex. So what we see is this P then would move up 2. So it would be up here, at a negative 3, 4. So my focus is going to be at a negative 3, 4. Now my directrix would move, because P is 2, my directrix would move 2 in the other direction. Since this point is already 2, it's going to go down to this point right here, and the directrix is going to be the line y equal to 0. Okay, it's been a few hours since I was last working on this video, so let me try to remember where I left off. So according to the instructions, we need to find the axis of symmetry, the vertex, the focus. Okay, so we've got the vertex. The vertex is a negative 3, 2. That makes the axis of symmetry x equal to a negative 3. The focus we found was a negative 3, 4. And the directrix would be 2 down from the vertex, and so that would be the line right here, the y equal to 0 line. And describe the transformation. Well, it's going to be a shift left of a negative 3 units and a shift upward of 2 units. Okay, let's move on to the next problem. This is the squared term here is y, so this is going to be a parabola that opens left to right. So let's draw a quick little diagram of it. It's going to have the vertex. Now, let's be careful here, because this is going to have the general form of x is equal to y squared, and then when I add in a shift, it's going to be x is equal to a, or which will be 1 over 4p, y minus k squared plus h. So look at how the h and k change positions from over in this parabola over here, which was a x squared. Y is equal to a x minus h squared plus k. So look at how the signs change. So what we have here is inside the parentheses with the y, we actually have k. So k is going to be equal to a negative 4. And the h would be equal to 2. So they're different signs than what I have over here when I had a y equals x squared. And let's go ahead and find the focus and stuff. So I know I can go ahead and put my vertex at 2. So the vertex is going to be at 2, negative 4, right? H value is the x. So let's go 2, negative 4. And now then let's go ahead and find P. So what we would have is, we know this piece right here is equal to 1 over 4p, right? Because if I wrote it like x is equal to 1 over 4p y minus k squared plus h, 1 over 4p must be equal to the a. So let's go ahead and set up a little equation. 1 over 4p is equal to a negative 3. So moving the p to the right-hand side, I would have 1 over 4 is equal to a negative 3p. Now dividing by a negative 3 would give me 1 all over a negative 12 is equal to p. Okay, so what that's going to mean, and this is going to be a parabola that opens to the left, right, because it's left-right and it's got a negative, so it's opening left. And the directrix will be to the right and the focus will be to the left. So if this is the point 2, I have 1/12 to the left is going to be the focus. So we're going to subtract 1/12 from 2. That would give me a value of, let's just do that scratch work up here, 12 minus 1/12 would be 1 11/12. So my focus would be right there, and it would have a coordinate. The x value would be 1 11/12, and the y value would still be a negative 4. So there's my focus. I've already found the vertex. The axis of symmetry would be at x is equal to 2. No, sorry. Let's try that again. The axis of symmetry is going to be cutting through here, which would be y is equal to a negative 4. And let's see what else I need to find. I need to find the directrix, so the directrix is going to be a line coming down over here, 1/12 on the right-hand side. So the directrix is going to be a line, and it's going to be a vertical line, so that would be x is equal to, and I already have, remember the vertex is at 2, negative 4, so 1/12 to the right would give me 2 and 1/12. So that's the line of the directrix. And as far as the shift, well, it shifted h units to the right and negative 4 units down. So 2 units right, negative 4 units down is where my vertex is, so that's the shift. Okay, now we're moving on to the last section, and it's modeling. And what we have to do is find the equation of a line that passes through 13.8 and has a vertex of 3,2. So let's go ahead and set up the general equation in vertex form. Y is equal to a x minus h squared plus k. And we know a vertex, so let's plug that in. That gives me y is equal to a x minus 3 squared plus 2. And I still can't write the equation of a line. I need to find this a value. When I find it, I could just plug it in. So I'm going to need to use the other point that I know, which is not a vertex, and I'll plug those values in for x and y so that I can find a. So this would be 8 is equal to a times 13 minus 3 squared plus 2. 8 is equal to a times 10 plus 2. So subtract the 2. Now divide by 10, I would get 0.6 is equal to a. So let's plug that into this equation right here, which has x's and y. And so my final answer would be y is equal to 0.6 x minus 3 squared plus 2. Okay, the next problem, we're doing the same thing, we're modeling, but we have something that's in intercept form because I know the intercept's not the vertex. So the intercept form of an equation is y is equal to a x minus p x minus q. And let's plug in the intercept point. So here we have x is a negative 1. So y is equal to a x minus a negative 1. And here we have the intercept point is 2. So I have y is equal to a x plus 1 x minus 2. So now we need to still find the value of a. Let's plug in a point that I know that I have not used. That would be this point over here, 1, negative 2. Let's put those values in for x and y so we can find a. So y is a negative 2. Let's plug that in. We've got a, and then we've got x, 1 plus 1. And then we have the x value, 1 minus 2. So that's going to be equal to a negative 2 is equal to a times 2 times 1 minus 2. That's a negative 1. So I have a negative 2 is equal to negative 2a. 1 is equal to a. Let's plug that into the equation where I have the x's and y's right here. So y is equal to 1 times x plus 1, x minus 2, and simplifying, y is equal to x plus 1, x minus 2. Okay, the last problem, as you notice, we have to model this. We have to find the equation for this data. And notice we don't have a vertex, and we have one intercept, but we don't have the second intercept. So we're not going to be able to use those two easy forms. We're going to have to use standard form for this. And I'll need 3 points. So let's just try to pick the easiest points that I know. Suppose I'll pick 0, 1, and 2 for the x values. Okay, so remember, standard form is y equals a x times x squared plus bx plus c. So my first equation, the x value is 0, the y value is 0. So let's go ahead and plug those in. So y is 0, so 0 is equal to a times x squared, and 0 for this point right here, x is 0, plus b times x, which is 0, plus c. So there's one equation. I'll just put a little 1 there. That's my first one. For the second equation, I'm going to have the y value, which is equal to 180, is equal to a times x squared, and x is 1, plus b times x, x is 1, plus c. And my third equation is going to be 720 is equal to a times x squared plus b times x plus c. Okay, so let's start simplifying some of this. So let's rewrite these equations. So the first one, I'm going to simply have a times 0, b times 0. So that simply gives the first equation is going to be c equal to 0. The second equation is going to be 1 squared times a, so that's just simply a. And then I have 1 times b, that would be plus b, plus c is equal to 180. The third equation is going to be 2 squared is 4, so I've got 4a plus 2b plus c is equal to 720. Okay, so we can simplify these more now. I know c is equal to 0, so let's just change c to 0. So I would have a plus b, c is 0, is equal to 180. And then I would have, for the next one, I would have 4a plus 2b is equal to 720, because c is 0. Now I have two equations and two unknowns. So let's go ahead and we'll take this first equation and we'll multiply it by -2. And that'll give me this set of equations. Be a -2a minus 2b is equal to a -360. So I have 2a plus 0b is equal to 360. And so a would be equal to 180. Okay, let's find b. So we'll substitute that into this equation. So I have a plus b is equal to 180. So what that would be is, so 180 plus b is equal to 180. I have a b is equal to 0. So finally, my equation is going to be, so I have b, I have a, and I have c. Remember, c is equal to 0. I have y is equal to ax squared plus bx plus c. Y is equal to a, which is 180x squared, plus bx will be a 0, and c is 0, so this will be my equation. And I think that's the last problem. Nope, there's one for the graphing calculator, but we haven't done that yet, so we'll just hold off on that.